Hello everyone, and welcome back to the channel. I am so happy to see you here today. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment. And for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I am here to help you succeed. Today, we are going to learn about a topic that is fundamental to further mathematics and additional mathematics. We are going to talk about matrices. This is part 1, covering the algebra of matrices. This lesson is suitable for SHS1 and SHS2 students. Now, I know that when you hear the word matrices, you might feel a little nervous. Many students find this topic challenging because there are many rules and calculations to remember. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes. So we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to define a matrix and identify its order, which means its dimensions. You will learn how to identify different types of matrices like identity, zero, square, and transpose. You will learn how to perform addition, subtraction, and scalar multiplication on matrices. You will learn how to perform matrix multiplication, and we will spend extra time on this because it is very important. You will learn how to calculate the determinant of 2 by 2 and 3 by 3 matrices. You will learn how to find the inverse of a 2 by 2 matrix. And finally, you will learn how to solve simultaneous linear equations using the matrix method. That is a lot, but we will take it one piece at a time. Let us start with section 2. Introduction to matrices. What is a matrix? The plural is matrices. A matrix is a rectangular array of numbers arranged in rows and columns. Think of it like a table or a grid. The numbers inside are called elements or entries. The order of a matrix is its size. It is given by m, by n. Here, m is the number of rows. Rows go horizontally, like rows of seats in a cinema. N is the number of columns. Columns go vertically, like columns holding up a building. Let us look at an example. Imagine a matrix A. It has 2 rows and 3 columns. The first row has the numbers 2, 5, and 1. The second row has the numbers 3, 0, and 4. So the order is 2 by 3. 2 rows, 3 columns. Notation is important. Matrices are denoted by capital letters like B or C. Elements are denoted by lowercase letters with subscripts. For example, a sub ij. Here, I is the row number and j is the column number. In our matrix A above, the element in row 1, column 2 is 5. So a sub 1, 2 equals 5. Please write this down. Understanding rows and columns is the foundation of everything we will do today. Now, let us move to section 3, types of matrices. There are several types you need to know. First is the square matrix. This is when the number of rows equals the number of columns. For example, a 2 by 2 matrix or a 3 by 3 matrix. Second is the zero matrix. This is a matrix where all elements are 0. It is denoted by the number 0. Third is the identity matrix. This is a square matrix with 1s on the main diagonal and 0s everywhere else. It is denoted by capital I. Think of it like the number 1 in normal arithmetic. When you multiply by it, nothing changes. Fourth is the diagonal matrix. This is a square matrix where all non-diagonal elements are 0. Only the diagonal from top left to bottom right has numbers. Fifth is the transpose. This is when you swap the rows and columns. The first row becomes the first column. The second row becomes the second column. It is denoted by a transpose or a prime. Please write these definitions down. You will need to recognize them in exam questions. Now, let us move to section 4, operations on matrices. First is addition and subtraction. There is a condition here. Matrices must have the same order to be added or subtracted. You cannot add a 2 by 2 matrix to a 2 by 3 matrix. It is like trying to add apples and oranges. The method is simple. You add or subtract corresponding elements. Top left adds to top left. Top right adds to top right. Let us look at example 1. Given matrix, A equals a 2 by 2 matrix. First row, 2, 3. Second row, 1, 4. Given matrix B equals a 2 by 2 matrix. First row, 5, 1. Second row, 0, 2. Find A plus B. We add the corresponding elements. Top left, 2 plus 5 equals 7. Top right, 3 plus 1 equals 4. This practice. Bottom left, 1 plus 0 equals 1. Bottom right, 4 plus 2 equals 6. So the result is a matrix with first row, 7, 4. Second row, 1, 6. Simple, right? Just match the positions. Next is squainer, multiplying a matrix by a single number, called a squainer. The method is to multiply every element in the matrix by that number. Let us look at example 2. Find 3A if A equals a 2 by 2 matrix. First row, 2, -1. Second row, 0, 4. We multiply every number inside by 3. Top left, 3 times 2 equals 6. Top right, 3 times -1 equals -3. Bottom left, 3 times 0 equals 0. Bottom right, 3 times 4 equals 12. So the result is a matrix with first row, 6, -3, second row, 0, 12. Remember to watch your signs. Positive times negative is negative. Now we come to the most important part of this lesson, matrix multiplication. I want you to pay very close attention here. This is where most students make mistakes, so I want you to wake up and focus. The condition for matrix multiplication is specific. The number of columns in the first matrix must equal the number of rows in the second matrix. Think of it like a key and a lock. The inner numbers must match. If matrix A is m by n and matrix B is m by p, the result AB is m by p. The n's cancel out, leaving you with m by p. The method is row by column. This is a dance. You take a row from the first matrix and a column from the second matrix. You multiply the first element of the row by the first element of the column, then the second element of the row by the second element of the column, then you add them all up. It is like a handshake. You need both hands to meet. You cannot shake hands with your elbow, so row must meet column. Let us look at example 3. Find a B if A equals a 2 by 2 matrix. First row, 1, 2. Second row, 3, 4. And B equals a 2 by 2 matrix. First row, 5, 6. Second row, 7, 8. We need to find 4 numbers for our answer matrix. Step 1. Row 1 of A times column 1 of B. Row 1 of A is 1, 2. Column 1 of B is 5, 7. Multiply first elements. 1 times 5 equals 5. Multiply second elements. 2 times 7 equals 14. Add them. 5 plus 14 equals 19. This goes in the top left of our answer. Step 2. row 1 of a times column 2 of B. Row 1 of A is 1, 2. Column 2 of B is 6, 8. Multiply first elements. 1 times 6 equals 6. Multiply second elements. 2 times 8 equals 16. Add them. 6 plus 16 equals 22. This goes in the top right of our answer. Step 3, row 2 of a times column 1 of B. Row 2 of A is 3, 4. Column 1 of B is 5, 7. Multiply first elements. 3 times 5 equals 15. Multiply second elements. 4 times 7 equals 28. Add them. 15 plus 28. 15 plus 20 is 35. Plus 8 is 43. This goes in the bottom left of our answer. Step 4, row 2 of A times column 2 of B. Row 2 of A is 3, 4. Column 2 of B is 6, 8. Multiply first elements. 3 times 6 equals 18. Multiply second elements. 4 times 8 equals 32. Add them. 18 plus 32. Let us do it slowly. 8 plus 2 is 10. Carry the 1. 1 plus 3 is 4. Plus 3 is 7. Wait, 18 plus 32 is 50. Let me count on fingers. 18, 19, 20, 50. Yes, 50. This goes in the bottom right of our answer. Result A, B equals a matrix with first row, 19, 22. Second row, 43, 50. I need to give you a very important warning. Matrix multiplication is not commutative. This means AB does not usually equal BA. In normal math, 2 times 3 equals 3 times 2. In matrices, order matters? It is like putting on your shoes and socks. If you put on your shoes first, then socks, it is different from socks first, then shoe. You will look very funny walking around with socks over your shoes. So do not swap the order unless you are sure. Now, let us move to Section 5, Determinant of a matrix. The determinant is a single number calculated from a square matrix. It tells us if the matrix has an inverse. It is like the heartbeat of the matrix. If the heartbeat is 0, the matrix is singular and has no inverse. It is denoted by vertical lines around the matrix, or det A, first for a 2 by 2 matrix. If A equals a matrix with AB on the first row and C, D on the second row, the determinant is a times D minus B times C. It is the product of the main diagonal minus the product of the other diagonal. Think of it as an X crossing the matrix. Top left to bottom right is positive. Top right to bottom left is negative. Let us look at example 4. Find the determinant of P. P equals a matrix with first row 4, 3. Second row 2, 5. Determinant equals 4 times 5 minus 3 times 2. 4 times 5 is 20. 3 times 2 is 6. 20 minus 6 is 14. So the determinant is 14. Next, for a 3 by 3 matrix. This is a bit longer. We expand along the first row. If A equals a 3 by 3 matrix with elements A, B, C in the first row, the formula is a times open bracket EI minus FH close bracket minus B times open bracket DI minus FG close bracket plus C times open bracket DH minus EG close bracket. Notice the signs, plus minus, plus. This is very important. Do not forget the minus sign for the middle term. It is like a traffic light. Green, red, green. Go, stop. Go. Let us look at example 5. Find the determinant of Q. Q equals a 3 by 3 matrix. First row, 1, 2, 3. Second row, 0, 1, 4. Third row, 5, 6, 0. We expand along the first row. 1, 2, 3. First term, 1 times open bracket, 1 times 0 minus 4 times 6, close bracket. 1 times 0 is 0. 4 times 6 is 24. So 0 minus 24 is negative 24. 1 times negative 24 is negative 24. Second term, minus 2 times open bracket 0 times 0 minus 4 times 5, close bracket. 0 times 0 is 0. 4 times 5 is 20. So 0 minus 20 is negative 20. Minus 2 times negative 20. Negative times negative is positive. 2 times 20 is 40. So plus 40. Third term, plus 3 times open bracket 0 times 6 minus 1 times 5 close bracket. 0 times 6 is 0. 1 times 5 is 5. So 0 minus 5 is negative 5 plus 3 times negative 5 is negative 15. Now add them all up. Negative 24 plus 40 minus 15. Negative 24 plus 40 is 16. 16 minus 15 is 1. So the determinant is 1. There are two types of matrices based on determinants. Singular matrix. The determinant is 0. No inverse exists. It is like trying to divide by 0. Impossible. Non-singular matrix. The determinant is not 0. Inverse exists. Remember this. If the determinant is 0, you cannot find the inverse. Stop there. Now, let us move to section 6. Inverse of a 2 by 2 matrix. The inverse of matrix A is denoted A inverse. When you multiply A by A inverse, you get the identity matrix. It is like the number 1 for a 2 by 2 matrix A with a B on the first row and C, D on the second row. The formula is 1 over the determinant times a new matrix. The new matrix is formed by swapping the diagonals and changing the signs of the others. So A and D swap places. B and C change signs. Mnemonic, swap the diagonals, change the signs of the others, divide by determinant. Say it with me. Swap the diagonals, change the signs of the others, divide by determinant. Let us look at example 6, finding the inverse. Find the inverse of A. A equals a matrix with first row, 3, 2, second row, 4, 5. Step 1, calculate determinant. Determinant equals 3 times 5 minus 2 times 4. 3 times 5 is 15. 2 times 4 is 8. 15 minus 8 is 7. So the determinant is 7. Step 2, apply the formula. Swap 3 and 5. So 5 goes top left, 3 goes bottom right. Change signs of 2 and 4. So 2 becomes negative 2. 4 becomes negative 4. So the matrix part is first row, 5, negative 2, second row, negative 4, 3. Multiply by 1 over the determinant, which is 1 over 7. So A inverse equals 1/7 times the matrix with first row, 5, negative 2. Second row, negative 4, 3. Step 3, multiply by scalar. This is optional. Usually we leave it as a fraction. But if we multiply, we get first row, 5 sevenths, negative 2 sevenths. Second row, negative 4 sevenths, 3 sevenths. Answer, A inverse equals the matrix with fractions as above. Please write this down. The swap and sign change is easy to forget in the exam hall. Write the mnemonic on your hand if you have to. Just kidding. Do not write on your hand in the exam. Write it in your notes. Now let us move to section 7, solving simultaneous equations. Matrices provide a powerful method for solving linear equations. It is like using a master key. The method is as follows. 1. Write equations in matrix form AX equals B. 2. Find the inverse A inverse. 3. Multiply both sides by A inverse. So X equals A inverse B. Remember, you cannot divide by a matrix. You must multiply by the inverse. Division is forbidden in matrix land. Let us look at example 7. Solving equations. Solve the system. 2x plus 3y equals 8. 5x plus 4y equals 13. Step 1. Write in matrix form. Coefficient matrix A is first row 2, 3, second row 5, 4. The variable matrix X is X, Y. The constant matrix B is 8, 13. So A, X equals B. Step 2, find the inverse. First, find the determinant of A. Determinant equals 2 times 4 minus 3 times 5. 2 times 4 is 8. 3 times 5 is 15. 8 minus 15 is negative 7. So the determinant is negative 7. Now apply the inverse formula. Swap 2 and 4. So 4 goes top left, 2 goes bottom right. Change signs of 3 and 5. So 3 becomes negative 3. 5 becomes negative 5. So A inverse is 1 over negative 7 times the matrix. First row, 4, negative 3. Second row, negative 5, 2. Step 3. Calculate X equals A inverse B. X equals 1 over negative 7 times the matrix product. Multiply the matrix by the column vector B. 8, 13. Row 1, 4 times 8 plus negative 3 times 13. 4 times 8 is 32. Negative 3 times 13 is negative 39. 32 minus 39 is negative 7. Row 2, negative 5 times 8 plus 2 times 13. Negative 5 times 8 is negative 40. 2 times 13 is 26. Negative 40 plus 26 is negative 14. So we have 1 over negative 7 times the column vector. Negative 7, negative 14. Now multiply by the scalar 1 over negative 7. It equals negative 7 divided by negative 7. Negative divided by negative is positive. 7 divided by 7 is 1. So X equals 1. Y equals negative 14 divided by negative 7. Negative divided by negative is positive. 14 divided by 7 is 2. So Y equals 2. Answer, X equals 1. Y equals 2. Always check your answer by substituting back into the original equations. 2 times 1 plus 3 times 2 equals 2 plus 6 equals 8. Correct. 5 times 1 plus 4 times 2 equals 5 plus 8 equals 13. Correct. C. It works. Now I want to warn you about common mistakes students make. Section 8, mistake number 1, matrix multiplication order. Multiplying column by row instead of row by column. Correction. Always row of first times column of second. Remember the handshake. Mistake number 2, commutativity. Assuming AB equals BA. Correction. It is usually not. Order matters. Shoes and socks. Mistake number 3, determinant signs. Forgetting the negative sign for the middle term in a 3 by 3 determinant. Correction. Remember the pattern plus, minus, plus, green, red, green. Mistake number 4. Inverse formula. Swapping the wrong elements or forgetting to change signs of the off diagonals. Correction. Swap diagonals A and D. Change signs of others B and C. Mistake number 5. Division. Trying to divide by a matrix. Correction. You cannot divide by a matrix. Multiply by the inverse instead. Mistake number 6, singular matrices. Trying to find the inverse when the determinant is 0. Correction, check the determinant first. If it is 0, stop. No inverse exists. Now it is time for class evaluation. Section 9. I want you to pause the video and solve these in your notebook. Question 1. State the order of the matrix with first row. 1, 0, 5. Second row. 2, 3, 1. Question 2. If A equals a matrix with first row, 2, 1. Second row, 3, 4. Find 2A. Question 3. Calculate the determinant of a matrix with first row, 5, 2. Second row, 3, 1. Question 4. Find the inverse of a matrix with first row. 1, 2, second row. 3, 5. Question 5. Write the matrix equation with matrix first row. 2, 1. Second row. 1, 1. Times column X. Y equals column 5, 3. As simultaneous equations, take your time. Write down your steps. Do not rush. I will wait for you for your assignment. Section 10. Please do these at home. Question 1. Given A equals a matrix with first row 1, 2, second row 3, 4, and B equals a matrix with first row 0, 1, second row 2, 3. Find a B minus 2A. Question 2. Find the value of X if the matrix with first row X, 2, second row 3, 4 is singular. Question 3. Find the inverse of a matrix with first row 4, 3, second row 2, 1. Question 4. Solve. Using matrices. 3x minus 2, y equals 7. 5x plus 4, y equals 19. Question 5 is a challenge. Calculate the determinant of a 3 by 3 matrix. First row, 2, 0, 1. Second row, 3, 1, 2. Third row, 1, 4, 0. Let us do a summary of what we learned today. Section 11. A matrix is an array of numbers with order m by n. Multiplication is row of first times column of second. A B does not equal B. A. Determinant for 2 by 2 is a times D minus B times C. Inverse for 2 by 2 is swap diagonals. Change signs of others. Divide by determinant. Singular means determinant is 0, no inverse. Equations are solved by X equals A inverse B. Identity matrix acts like the number 1. Here are some teacher's tips for WAEC. Matrix multiplication is the most conceptually difficult part. Use colored chalk or markers to trace the row and column being multiplied on the board. Emphasize that division by a matrix is impossible. Instead, we multiply by the inverse. When solving equations, remind students to check their answer by substituting back into the original equations. And always check the determinant before finding the inverse. I know this was a long lesson, but you have done amazingly well. Matrices can be confusing because of the many rules, but you now have the tools to handle them. Remember, practice is the key. The more you practice multiplying matrices and finding inverses, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there is a specific problem you are stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.